my name is Nyte Teeter, and today I'll be showing you how to use trigonometric identities. This will involve Pythagorean identities and defining relations between different trigonometric functions and applying their usage into our problems today. Now, first off, right away, I'm noticing a Pythagorean identity, and that is sine squared theta plus cosine squared theta is equal to 1. Now, I know this doesn't look exactly like what I just said, but let me put it this way. How do we isolate sine squared theta in this equation right here? Well, we have to subtract cosine squared theta from both sides. And what that would end up looking like is sine squared theta is equal to 1 minus cosine squared theta, which is what we actually have right here in this numerator. So I'm going to substitute in our sine squared theta into our numerator, because that's what we just determined is equal to 1 minus cosine squared theta. Now, I'm going to take the exact same approach into cosine squared theta. If we want to isolate that, we subtract sine squared theta from both sides. And that would end up looking like this. Cosine squared theta is equal to 1 minus sine squared theta. And 1 minus sine squared theta is what we see in our denominator. So I'm going to rewrite that as cosine squared theta, which now gives us a more simplified version than we had before. However, this is not as simplified as we can get, because sine theta over cosine theta is actually, equal to tangent theta. Now, the only difference in our equation is that we have sine squared and cosine squared. That doesn't really matter. It just means we have tangent squared theta. So, because sine over cosine is tangent, we can rewrite our equation of sine squared theta over cosine squared theta into tangent squared theta. And that is the most simplified version of question 1. Now, that was an easy problem. Let's move over to question 2, which is a little more difficult, however, very manageable. And once you go one step at a time, it's actually fairly simple, and you'll be able to do it pretty easily. Now, I'm looking at this numerator. It's looking pretty complicated. I want to attack this first. Let's start with this right here, the sine squared theta plus cosine squared theta. I'm immediately recognizing this from earlier as our Pythagorean identity over here. Sine squared theta plus cosine squared theta is equal to 1, right? So I'm going to just rewrite this right away. 1 minus sine theta over cosecant theta. And that is our first step in simplifying this numerator. And now we have to bring down the rest of our problem and continue from here. Now, I still want to go at this numerator. So what I'm going to do next is something that I've always found to be very useful, trying to get all of our terms similar. And usually I'll go towards either sine or cosine. Now here, looking at it, we already have sine up here. So I want to be able to turn this cosecant into something with our sine. And cosecant is actually equal to the reciprocal of sine. So cosecant is equal to 1 over sine theta, or the reciprocal of sine. So I'm going to substitute that into our equation. And I know I said I wanted to simplify the numerator and I'm just adding another fraction into it, but in a second you'll see how this is exactly what we need to do. So it becomes 1 minus sine theta over 1 over sine theta. Now, we have to bring down the rest of our problem. sine squared theta plus 1. And now, up in this numerator up here, we're dividing by a fraction. Now, what do we do when we're dividing by a fraction? We multiply it by its reciprocal. So, instead of it being sine theta divided by 1 over sine theta, we'll turn it into sine theta times sine theta over 1. And sine theta over 1 is just sine theta. So it's really sine theta times sine theta. So I will rewrite it like that. And then we put it over sine squared theta. And we add 1. Now, I'm going to just simplify this. Sine squared, or sine theta times sine theta is sine squared. Kind of gave that away. But, I mean, I'm sure you knew that. Sine squared theta. Bring the rest down. Sine squared theta plus 1. Now, right back at this 1 minus sine squared theta. Where have we seen this before? We saw that up here. 1 minus sine squared theta. What did that turn into? That turned into cosine squared theta. We can just go right back at it with that Pythagorean identity. Turn it into cosine squared theta over sine squared theta plus 1. Now, earlier, we had sine squared over cosine squared theta. Now we have cosine squared theta over sine squared theta. This is just the reciprocal of tangent, right? Because instead of it's sine over cosine, it's cosine over sine. It's just the reciprocal. And what is the reciprocal of tangent? The reciprocal of tangent is cotangent. Okay, so because this cosine squared theta over sine squared theta is the reciprocal of tangent, we know that it's actually equal to cotangent, right? Because both of these are equal to the reciprocal of tangent. So that means that cosine squared theta over sine squared theta is going to be the reciprocal of tangent squared theta, which is cotangent squared theta. And can't forget about the plus 1. Now, this right here is a different trigonometric or Pythagorean identity that we haven't seen yet, but it is one that we should know. Cotangent squared theta plus 1 is actually equal to cosecant squared theta. And we see the cotangent squared theta plus 1 over here, and we see it over here on the right. So we can just substitute in our cosecant squared theta here. Cosecant squared theta, and that is our most simplified version of this problem. So it may have taken a while, shown a lot of work, gone step by step, but if you just know your Pythagorean identities, know reciprocals, know things like that, you can easily get from your initial problem to your end result in the max simplified version. Thank you for listening, and I hope you were able to take something away from this.